For over a century, cars have been a symbol of freedom and progress. They started with noisy, inefficient gasoline engines. Over time, these engines became more powerful and reliable. But the basic idea stayed the same: burn fuel to make the car go. Now we are on the edge of a new era in transportation. Electric vehicles, or EVs, are quickly becoming more popular and affordable. Instead of gasoline, they run on electricity, offering a cleaner and more sustainable way to travel. This shift to EVs is not just about swapping out the engine. It's about changing how we think about cars, energy, and even our cities. And it's happening faster than many people realize. Electric vehicles represent a fundamental shift in how we power our transportation. They offer several key advantages over traditional gasoline-powered cars. First, they produce zero tailpipe emissions, meaning they don't release harmful pollutants into the air we breathe. Second, EVs are incredibly efficient. They convert a much higher percentage of energy from the grid into actual power, unlike gasoline engines that waste a lot of energy as heat. This efficiency translates to lower running costs for drivers, since electricity is typically cheaper than gasoline. Finally, EVs are remarkably quiet. Gone is the roar of the combustion engine, replaced by a near-silent hum. This reduction in noise pollution can make our cities more pleasant and livable. The shift to electric vehicles requires us to rethink the materials we use to build cars. Traditional cars rely heavily on steel for their body and frame. However, EVs benefit from lighter materials like aluminum and carbon fiber. These materials make the car lighter, which in turn increases its range and efficiency. Furthermore, EVs utilize powerful rare earth magnets in their electric motors, highlighting the need for sustainable sourcing and recycling of these crucial elements. The production of EVs also demands a greater focus on renewable energy sources for manufacturing processes. This shift towards sustainable materials and manufacturing is key to realizing the full environmental benefits of electric mobility. The rise of EVs is causing a major shift in the global economy. Traditional car manufacturers are investing billions in new factories and technologies to build electric cars. This transition is creating new jobs in areas like battery production, software development, and charging infrastructure. However, the shift is also displacing workers in the traditional auto industry, particularly those involved in the production of gasoline engines and transmissions. Governments and industry leaders need to collaborate on retraining and reskilling programs to ensure a smooth transition for workers in this evolving landscape. The widespread adoption of EVs will also have significant implications for energy markets. As demand for electricity from EVs increases, power grids will need to adapt to handle the increased load. This will likely drive investment in renewable energy sources and smart grid technologies. While the future of electric vehicles seems promising, there are challenges in sourcing the materials needed for their production. Batteries, in particular, require large amounts of lithium, cobalt, and nickel materials that are often mined in environmentally sensitive areas. Ensuring ethical and sustainable sourcing of these materials is crucial. This requires closer collaboration with mining companies, governments, and manufacturers. Investing in recycling technologies for electric vehicle batteries is also critical to reduce waste and lessen the environmental impact. Overcoming these challenges presents an opportunity to create a more resilient and responsible supply chain for the electric vehicle industry, one that benefits both the environment and local communities. Section 6. Powering Up. Advancements in battery technology. Battery technology is at the heart of the electric vehicle revolution. The cost of batteries has been a major hurdle to EV adoption, but thankfully, that is changing rapidly. Researchers are constantly working on new battery chemistries and designs to improve energy density, charging speed, and lifespan. Solid-state batteries, for example, promise significant improvements in range and safety compared to current lithium-ion batteries. Moreover, advancements in battery management systems and charging infrastructure are making it easier and more convenient to charge EVs. As battery technology continues to advance, we can expect to see even more affordable, longer range, and faster charging EVs in the future. This will further accelerate the transition to electric mobility and make it accessible to a wider range of consumers. Section 7. A breath of fresh air, environmental impact of EVs. One of the most significant benefits of electric vehicles is their potential to reduce greenhouse gas emissions and combat climate change. Unlike gasoline cars that release harmful pollutants, EVs produce zero tailpipe emissions, leading to cleaner air and healthier cities. However, it's important to remember that the environmental impact of EVs depends on how the electricity used to power them is generated. If the electricity comes from coal-fired power plants, the overall emissions reduction will be less significant. Therefore, it's crucial to accelerate the transition to renewable energy sources like solar and wind power to maximize the environmental benefits of electric vehicles. A clean energy grid, combined with widespread EV adoption, can significantly reduce our carbon footprint and create a more sustainable transportation system. Section 8. Designing for Tomorrow: Urban Planning in the Age of EVs. The rise of electric and autonomous vehicles presents an opportunity to rethink how we design our cities and infrastructure. With fewer gas stations needed, we can reclaim valuable urban space for parks, green spaces, and pedestrian-friendly areas. The widespread adoption of autonomous vehicles could also lead to a decrease in the need for parking spaces, freeing up even more land for other uses. Smart city technologies like intelligent traffic management systems can optimize traffic flow and reduce congestion, making our cities more livable and efficient. This transition requires careful urban planning and collaboration between policymakers, city planners, and technology companies to create a seamless and integrated transportation system for the future. Section 9. The Road Ahead: Visions of a Driverless Future. As we look to the future, the lines between electric vehicles and autonomous driving begin to blur. Self-driving cars, powered by electricity, hold the promise of safer, more efficient, and more accessible transportation for everyone. Imagine a world where traffic accidents are drastically reduced, where commuting becomes a time to relax or work, and where people with disabilities have newfound mobility independence. While there are still technical and ethical challenges to overcome, the potential benefits of autonomous driving are too significant to ignore. The journey towards a fully autonomous future will be gradual, with increasing levels of automation introduced in stages. As we navigate this uncharted territory, it's crucial to prioritize safety, equity, and sustainability to ensure that this technological revolution benefits all members of society. The future of transportation is electric, autonomous, and full of exciting possibilities. By embracing these advancements responsibly, we can create a cleaner, more efficient, and more equitable transportation system for generations to come.